Professor Wergeles here, making some final touches to our AudioViz challenge. You'll see here when I play the audio file, if I select some of these other visualizers, you'll see some movement here, even though the frequency is not being activated that much. But if I go to my visualizer, you'll see these ellipses aren't moving at all. So I'm not really taking advantage of the user interface space. So whenever you're making industry standard applications, I have some interface space over here that's not being used. So I have some real estate that's not being used, and I should take advantage of that and use the available space that's given. So you'll want to think about this for your visualizer as well. So if I look at visualizer 2, I still have some movement going on here. So this visualizer is acceptable. But for this visualizer, there's nothing happening here. Okay, so we're going to be looking for some small details like that. See if you took advantage of the real estate space. So how can we fix this? Well, in the previous videos, we talked about it a little bit. We increased the multiplying factor here. So on the lower frequencies, on the lower bands, we multiply by 5, and that's plenty of movement. Maybe on some of the really high frequencies that aren't activated much, we multiply by a larger number. So in the example, I think we multiplied by 90 or 100. We went to an extremely large number, and then we changed the normalization factor. So we scaled it much larger and then normalized the value so it makes sure that we stay in that same range. But another simple solution would be just use the lower frequencies. In fact, if you look at some of these high frequencies, they're so high that the human ear will have a hard time hearing them. So if they're that high, then we can just use some of the lower frequencies. So for example, when I is from 0, and you'll see all the way to about halfway, to the halfway point, I get some good movement. And you'll see some movement past the halfway point. Okay, so you'll see actually almost 3/4 would be acceptable. But past 3/4, there's not much movement. So if we take the halfway point, what we can do is use some of these low frequencies and replace them over here at the high frequencies. So we'll get almost like a U effect. So these low frequencies will also be activated over here. So then we'll get all of the ellipses to be activated. Okay, and that's actually really simple to implement. I can take this for loop, and essentially instead of going all the way through, I'm going to take the number and only go halfway, num divided by 2. And then for the second for loop, I'm going to start at the end of the array. So I'm going to start at num, and I'm going to go all the way down to less than or equal to num divided by 2. And then I'm going to decrease I by 1. Now, if I run this at this time, let's see what happens. So be careful when changing these algorithms here. The more for loops we have, the more updates we need to do, the more manipulations we need to calculate. Therefore, some computers won't be able to handle large amounts of bands. So be careful how many statements here that we're updating. But in this case, having 2 for loops sequentially, for my computer, it was able to run. So I'm going to run that. And actually, when I click on my visualizer, you'll see now only half of the ellipses are being displayed. So the first for loop's working, the second for loop's not working. So what happened here? We got an array index out of bounds. Well, we can think about what's happening. So let's say ellipses is 4, magnitudes is 4. When I come down here, I'm going to start at 4, but the maximum index is going to be 3. It's going to be from 0 to 3. So I need to say num minus 1, go halfway down, and then let's see what happens. So now we'll at least be able to run the program without it crashing. And if I run the program again, play a song, select my visualizer, you'll see the program's not crashing, but it's essentially the same as what we had before. About 3/4 of the ellipses are moving and the other 25% is not. So what's happening here? Well, if I start I at the maximum number, so I'm going to start at the end of the ellipses, that's fine. But I'm also using I as the magnitudes. So it's also going to start at the end of the magnitudes list. So essentially doing this is the same as what we had before. This one's going to start from 0 and go to halfway, and it's going to have ellipse 0 with magnitude 0. And this one's going to start at the end of the array. So for example, let's say there's 4 ellipses. This will start with ellipse 3, and it will also use magnitudes 3. So it'd be the same as this for loop here. But what we want to do is use ellipse 3 with magnitude 0. So I'm going to create another index. Let's call it X for now. And I'm going to use X here for this magnitudes value. Now, there's several ways to implement this. I'm just trying to get this up. as a quick example to show you and give you ideas of what you could do. Make sure you increment X, otherwise it's going to continue to be 0 and they'll all be the same. Run the program, click play, switch to your visualizer, and now you'll see we're taking advantage of all the real estate. So every ellipse is moving, no matter how many number of bands I specify. So even if I specify 140, okay, you'll see all the ellipses are moving. Now this is what we are looking for. Now, in some cases, you may not want your visualizer to look like this. It has a U shape, and I'm not taking advantage of the high frequencies, but they weren't being activated anyway. So some students may think this is a bad idea. That's fine. Change your normalization factor, update the display in a different way. But for my visualizer, now I'm taking advantage of all the ellipses. None of them are being idle for the entire portion of the song. And this was the solution that I came up with. Now, we didn't talk about this, but we can play videos as well. So while your song is playing, test and try to open up another MP3 or open up a MP4. If I open up the Tom and Jerry video that was in the previous lecture, you'll see I have a media view over here so I can see the video, and now it's taken the audio contents from the video. So your visualizer doesn't have to be purely based off of audio only. You can also specify a video here if you'd like, or maybe your visualizer has a video as the background and you update contents on the video based off of the audio from the video. Okay, you'll see how accurate the audio spectrum is. So as the sounds are occurring, you can see that being updated on the visualizer. Now, my visualizer is being cut off, so you'll see here I can't see the low frequencies. So we need to fix this. There's a video here, and now I'm not able to see my low frequencies. So we need to fix this. Make sure you test your visualizer on all these small cases. Can I pause? Can I stop? Can I move the slider? Can I switch the number of bands? Can I go to another visualizer and come back? We're going to fix up the UI. Stick with Professor Wergeles, and we'll see you in the next video.